In this video, we shall look at the Riemann sum as a way of estimating the area under the curve. So we want to consider the function y is equals to the function of x defined over the interval AB. That is from this point A up to B. Now, to estimate the area under the curve, we need to divide the interval AB into n sub-intervals, which we shall call x0, x1, x2, and so on, such that A will be our first endpoint there, x0. This is x1, x2, x3, and so on and so forth. The second last here, xn minus 1, and b will be xn, such that all these sub-interval, they add up to n of them. And each of these sub-intervals is of uniform width. Their widths are the same, which we are calling delta x. That is, the distance from x2, for example, to x3 is delta x, or the distance from x1 to x2 is delta x. And delta x, we can say, is this distance from A to B, and divide by the number of subintervals n, and that's why we have delta x is the same as b minus a over n. So let the endpoints be x0, which is equals to a, x1, x2, x3, such that x1 will be the same as a plus delta x. x2 is equals to a plus 2 delta x, and so on and so forth, until you reach the last one, xn, the same as a plus n delta x is equals to b, which is the last endpoint. Now, we want to take a point between these endpoints. For example, between endpoint x2 and x3, we take a point here, which we are referring to them as x stars, such that the first one in the interval x0 to x1 will be x star 1, and the second one between endpoint x1 and x2 will be x star 2. The next one will be x star 3, x star 4, up to the last one here. This point will be x star n. Now, this will be the height of each sub-intervals. What we mean is that if we consider one of these sub-intervals, let us try to magnify and only think of the first sub-interval, that is x0 to x1. x0 to x1, and we have chosen the point between those two endpoints, and this point is x star 1. So if we magnify for our purposes, if this is x0, which is the same as a, then the next endpoint is is x1, then we are choosing a point, any point between these two endpoints, which we are calling x star 1. So this, we are saying it's the height because if we consider, remember we are dealing with y as a function of x, so the height of this particular one will be f of x star 1, f of x star 1, and recall that the next one then will be f of x star 2. If I extend a little bit, maybe let's assume that this is our x2. This is our x2. So the height, we shall take it at point x star 2, and it will correspond to f of x star 2. This is the height, f of x star 2. F of x star 2 to be the height of each subintervals or rectangles. Rectangles, because if we extend this endpoint x naught and extend this height f of x star 1, so that this line touches x1, then we shall have the rectangle here with the height f of x star 1, and remember the subintervals are of with delta x, and this other one we can extend this x1 like that we have this rectangle. The area of this rectangle will be height times width, and the height is f of x star 2, and remember the width again is delta x. So we can go on like that until we reach the last subinterval with the height f of x star n, f of x star n, and therefore that rectangle, its area will be f of x star n times delta x. So the area below the curve will be approximately the areas of all these subintervals. So the first subinterval, the area will be f of x star 1 times delta x. The second one will be f of x star 2 times delta x, and so on up to the last one, which is f of x star n delta x. And we can say that this area will be the summation of f of x star i's times delta x, and I is from 1 up to n, and this is what we call the Riemann sum.